Alrighty, everybody, we just got it okay to start our final planetarium show of the day. So for now, folks, I'm going to be putting away our space trivia questions and that important message up on screen, because now, folks, we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, good afternoon, everybody. Good to see you. But don't hurt your necks. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow all throughout the room. And I'm happy to announce that the show that we're going to be watching right now is one of my favorites. This one's different from all the ones that we've done here today. This one's called Tour of the Universe. And so for the next 30 minutes, you're going to be hearing my voice completely live as I free fly us through space, and we're going to be starting off pretty close to the Earth, and we're going to zoom all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a forewarning, we're pretty small in the grand scheme of things, so just a heads up. But before we get started with the show, I got to go over some quick house rules just so that we're all on the same page and have a great time in here. First off, folks, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away to the end of the show. We want to keep the theater as clean as possible. We really do appreciate your help. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light, now is a really good time to put those devices away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And folks, if you need to exit early during our show, you're more than welcome to do so. The exits are always going to be at the very top of the planetarium, so always make your way up the stairs to exit. If the stairs are too steep for you, do not worry, we understand. All you have to do is just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit so that you don't have to climb those steep stairs. Just stay seated for a little bit longer. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual, at least. Hee hee hee. But with that being said, it looks like we're ready to go, so invite y'all to sit back, relax, and let's begin our tour of the universe. All right, folks, let me just re-grab the controls here. And like I said, we're going to be starting off pretty close to the Earth, but not quite. We're just above our planet. And we're starting off here at this really cool spacecraft in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I always hear about it in the news and articles. I don't really know what it is. Could you explain it for us? Well, of course, folks, the International Space Station is a research facility. It's a laboratory that orbits around our planet Earth, and they conduct so many different types of experiments up here on the ISS. Some of the experiments they'll conduct are things like what happens when you try to grow plants in space, which way do the roots grow with less gravity? Another one that they've tried is what happens when you try to spark in matches in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compared and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have as much gravity working down on your muscles constantly. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, do not worry. You can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And what's really impressive is that this thing is going incredibly fast. The ISS travels at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this looks really far away from our planet, but it's not too far either. The ISS is only about 225 miles above the surface of our world. 225 miles, that's not too bad for us Californians. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans into space nowadays, only 225 miles above the surface of our world. The reason why is because, well, traveling into space is very expensive. You got to build yourself a rocket ship, or buy yourself one, or pay for a ride, and that's pretty expensive. And then once you acquire that, you have to account for all the rocket fuel. You got to be able to leave the Earth's gravity. And once you're up here in space, you have to account for all the food, water, all the air you're going to be breathing, so the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop in our tour of the universe. So now we're going to see it slowly fade away down to the city lights down below. It looks like we're hovering just above Cairo, Egypt at the moment. And before we lose track of the ISS, I want to add a nice little trail so we can keep it in sight as it starts to slowly disappear. And now, folks, all the way out here, we're able to see our entire planet Earth. And I want to let you know that the space program that I'm using here in the planetarium is something that you can go home and download if you want to fly through space just like how I'm doing. The space program that we're using in here is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across the link where you can download it. You can also go to OpenSpaceProject.com. But just to let you know, folks, this program is not entirely finished. It's in its beta phase, so we may come across a few bugs and glitches, although it's been acting very good lately. So if we do see anything out of the ordinary, I'll point it out. Hopefully we can look past it. Also, OpenSpace uses a whole lot of processing power, so if you wanted to download this and you have an older computer, you may want to rethink it. But if you have something newer or a gaming computer, give it a try. It's so much fun. But in here, we're using OpenSpace. And now that we got a sense of what we're using, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions. That brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we need to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we'll be doing that. And what's really amazing is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more smaller, compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there. And that's going to be very helpful because we can melt that ice, pass electricity through it, we could separate the hydrogen and the oxygen, and both that stuff's very valuable when you're way far away from home. But again, look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, when we look up at the moon here from planet Earth, the moon feels incredibly close sometimes. Feels like you can reach out your arms and touch it. But the moon's incredibly far away. It's about 240,000 miles away from our planet Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months non-stop going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles, it's kind of like using inches to describe the distances between cities. So because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, well, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. So cute. And now, folks, we're going to see the moon and the Earth in their orbits as they start to slowly fade away, just like how we saw with the International Space Station just before. And just like before, I want to add some nice planet trails so we can see where everything is all the way out here in space, because again, space is really, really big. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now, folks, the nearest star to us, the sun, should be coming into view. So here comes the sun. Do-do-do-do-do. And the sun is also incredibly far away from our planet Earth. It's about 93 million miles. Whew, that's a good distance away, 93 million miles. Now, in order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light. And this is a really cool concept to keep in mind, because let's say the sun was to turn off all of a sudden, there was no more sunlight being emitted. That last bit of sunlight will travel that 93 million miles, that 8.5 minutes at the speed of light, and then all of a sudden the daytime on Earth would become nighttime. And again, this is such a great concept to keep in mind. The reason why is because let's say we're looking at a star that's 70 light years away. We're looking at that star as it looked like 70 years ago, because the light that just reached us took 70 years to get to us. So when we look at really far away objects in space, it's like looking back in time in a sense, which is really, really cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle of our solar system, we have our star, the sun. The closest planet to the sun, we have Mercury. Then we have Venus. It's really hot there. And then Earth. That's us. And then past Earth, we have Mars, the red planet. And then past Mars, we have the main asteroid belt. And this is what it would look like to highlight all the asteroids in the asteroid belt. There is a lot of them, roughly about 1 million asteroids in this region. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all, Saturn, famous for its rings, and then we have our icy gas giants. We got Uranus and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, just on the very top right hand of our screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And I know a few of you in here are probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, that's a lot of stuff. So the Kuiper Belt is like a second asteroid belt past the orbit of Neptune. And what you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And what's really fascinating is that we came across this stuff roughly in 2006. That's when our technology and telescopes greatly improved, so we're able to see much smaller objects much further away. And in 2006, we found more than 400 objects out here in the Kuiper Belt region, and some of this stuff was bigger than Pluto. So we couldn't call all these things planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And that was the day in 2006, folks, that they came up with 3 different criterias, and that's when Pluto went from being a planet to a dwarf planet. But that's the really cool thing about science, because as our technology improves, we're able to make better observations. So science is constantly updating and changing, and I love that about it. But for now, I'm going to put away the Kuiper Belt region, because that's just a whole lot to look at. And now I'm going to be adding on screen some many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to get all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours, not too bad. But now, folks, it's time for us to leave the planetary scale behind us, because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri just flew by us on the left-hand side. So again, we're right in the middle of our screen. Alpha Centauri is on the left hand, that star that's moving. Again, 4 years at the speed of light just to reach the next star system to us. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Folks, if you were to get in a rocket ship today, make your way over to Alpha Centauri, it's going to take you roughly about 8,500 years to make that journey. Whew, and that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the Radiosphere. And again, we're now inside something called the Radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later, the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before the early 1930s, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they're all traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it, specifically for us humans. Now, so far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed, created at the moment, so we got a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signal. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the far left of our radiosphere. Let's say this one right here on the left. We find an alien civilization somewhere on the other side of the radiosphere. Let's say this one. We send them a text message. We say, hey, we're humans, we're friendly. Take 60 years to get to them. They listen in, answer back. Another 60 years to get the reply message. Folks, that is a 120-year conversation in the making. Whew, and I could barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet. But eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. All right, folks, we're now looking down on our Milky Way galaxy. This is the galaxy we live in, and I have to ask, can anybody see their house from here? And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you roughly about 130,000 years at the speed of light. This thing is huge. And our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from the side. You're going to notice that we live in a big flat spiral disk of the Milky Way. Kind of looks like a big pancake or a frisbee. And this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. There's not one galaxy here in a nice little neat line, another galaxy here in a nice little neat line. Galaxies like to clump together, where they stick together, or they like to avoid each other, where they create voids where there's very few galaxies or no galaxies at all. So we can see a nice galaxy clustering towards the center of our screen. We can see some voids or empty space on the left-hand side of our dome on our screen. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tolley, who compiled this amazing representation thanks to the work of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tolley. I love flying through this galactic map. But now we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And remember when I said that we live in a big flat spiral disk of our Milky Way galaxy? Well, if you're lining up our Milky Way galaxy, it would line up just right down the middle. So the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. And the reason why we see this shape is because, again, of our Milky Way galaxy. It would line up just down the middle, up and down, vertically like so. So again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way. But astronomers still want to make sure that there was galaxies through the plane of our Milky Way, so we had this purple survey of galaxies. You'll notice that they were still able to find them, just not as many and not as far. Pretty much we had to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. Whew! And speaking of time, we're running close out of time. So let's continue pressing on, folks, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are represented by orange dots on either side of the large-scale structure of the universe. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are at the very edge of the observable universe, folks. What we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. All evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to a large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to head, which is going to be back home towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And let us make our return trip back to planet Earth, everybody. All right, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and see into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. And it looks like we just made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And now we're making our way back to our star system, our solar system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto in the Kuiper Belt region, making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And if you want to share this exact show with your friends or family who are unable to visit today, well, you can share this exact show if you go to the Morrison Planetarium Facebook page or the California Academy of Sciences YouTube page, and you can share this video with them, and it's a whole lot of fun. But otherwise, it looks like we made it back home just in time for dinner time, and that's all the time we have for today, folks. And I want to thank you all for stopping by, and I hope you get home safely. Thanks for stopping by and watching our show.